This demo, I will be showing the general steps for identifying correlations between demand and events. My name is Lina Khatib, and I'm the Data Science Solutions Engineer at PredictHQ. So those steps work for all industries. However, we're demonstrating it for the ride-sharing or ride-hailing demand. So the first two items you need to identify here is the demand file and the aggregate event impact file. And those were for Austin. This is the ride-hail demand. This is the aggregate event impact. And we have it for January 1st through April 13 of 2017. Those are both CSV files. And second, you need to identify the specification for the demand file. So we need at the minimum the demand columns, which is number of trips here. It could be something else for your demand. And the date columns, it's called trip and timestamps, trip to hours. That's how it was trimmed, the name of it. And the date scale, so the data is given per hours. And what we're gonna be establishing correlations over, in this case, it's a day. So that's what we're gonna see later. For the impact file specifications, we have the impact columns. It's called total impact here, and the date is the date time. So that's the only cell you need to input data with, and once it's done, all what you need is to go to cell and hit run all, and it's gonna run everything. So once we have this data, let's see what we need to do. Typical things: import needed libraries, and now read the demand file. We read the demand file, and this is how it looks. This is the date first columns, and the second column is the demand, which are represented by number of trips. The second step is to prepare the demand data frame and time series. We just standardize the columns name, and then we aggregate over a day if it's not already been aggregated, because right now we're gonna try to establish correlations over a day. And we build the demand time series from the data frame. And this is the output. So the demand data frame looks like this. We have date time demand, and the demand time series looks like this. Now the date time became an index, and the demand is the only columns here. So the first computations we need to do with this time series of the demand is to decompose it into the typical 4 components. Here I'm using the RSTL package, but you could use some others one. So here we had it decomposed, and if the trend was not computed well by the package, packages are usually not perfect for every domain. They're very helpful, but sometimes you need to do some adjustments to them. So we do smoothing of the trend, and what we end up with is the following, which I'm going to illustrate it on the charts here. So the decomposition will take the demand, this is the number of rides, and along the time series, this is how they look. And the decomposition will compute the seasonality here is very cyclic. It looks like it's weekly. so there's no issues here. And it has the trend. The package brought the trend to look like this. This should not be here, it should be smoothened, and this is what we do in the next step. And it's going to compute the remainders, sometimes it's called residuals. And what we're gonna interpret these remainders or residuals here to be the unexpected domain, either increase or decrease. And for now, we're focusing on the incremental demands, meaning the remainders that are positive and high enough, so they make for an unexpected high demand. So that's our focus area, but we need to take care of this part here because the trend here came not smooth enough, too high, so it's taking away from the remainder. So we do few steps just to smoothen this one here. And since we're focusing only on the incremental demand, so we're going to focus on the positive part of the remainder. And we're going to use the moving average in order to smooth the trend. And we use 29 here, which fits the domain. And that's the new trend here. And we have computed what the adjustment we need to do with the trend. And again, we're focusing only on the incremental demand, so we clipped at 0. And finally, the incremental demand, or the remainder, or the residuals, they come in different names. Those are going to be mapped here, and this is the most important part for us. There's a common mistake that establishing correlations between events and demand, it's attempted to establish correlations between the actual demand data. However, that's incorrect because we want the events to predict or to help with forecasting for the unusual demand. The typical one, the regular one, it can be computed by autoregressions or by knowing what's there. However, we want the events to help with the unexpected demand, so that's why we focus on the residuals, remainders, or what we call incremented demand here. Everything down lower here, meaning expected. This big hump here in the remainder, this is unexpected, and this is what we're focusing on to see if there is any event that explains it. So looking at this incremental demand, if we plot it into a bigger chart, it's going to look like this. And we see it is happening here around 2017, around March 17 here. So we need to see if there are other events that explain it. Here we have another incremental demand, not as severe as here, but again, we need to see if we can explain it. Here we just try to see some statistical information here. We try to get the incremental demand and plot it. And it's histogram here. So this means here we have incremental of zeros, here of 1,000, not much. Here we have an incremental of 7,000. So somewhere here we need to draw a cut and focus on the high of the incremental demands. All of those statistics work. So we try to identify the significant incremental demand by having standard deviation cut. A common one is to have 1.5 of the standard deviation. So if we use the 1.5 of the standard deviations, we end up with 7 days within that period where we had higher than expected demands that are significant enough to evaluate. Someone might want to get a lower cut, like only one standard deviation. You could do that if your domain asks for it. So that's the step. We finished processing the demand files. Now we get to the aggregate event impact files, and we process it in the same way. Basically, we want to generate a time series from it. So here is our files. It has 100 days in it, and in this case we have 18 columns, what our APIs return for us. And those are the columns. We have a date time, which is important, and then we have other events happening, airport delay, community, concert, disasters, etc., etc. In this first step for establishing correlations, I'm most interested in the date time and the total impact, which is, we have it here. Later on, for future more advanced correlations, we might be using other impacts as well, but for the purpose of this demo, I'll keep it simple and just use one of them. So we prepare the aggregate events impact data frame and time series, exactly the same way we did with the demand. So we end up with the data frame looking like this, and its time series looking like this. And what we need to do is to plot the aggregate event impact against the incremental demands. Again, we're focusing only on the unexpected part of the demands, the unexpected increment. Some wish to call it outliers, or you could call it just whatever name you can give it. All what it is, just like the things that's above the expected one. That means it hasn't been detected via regular historical data. So we're focusing on that when we plot them against each other. So that incremental demand is the orange part, and the blue demand here is the aggregate event impact part. And they're of different scales. Once the scale goes to this number, 350K, the other one goes up to 7,000, but you can plot them against each other with normalization over the plot here. And what we notice here, if we go back to our original, that's the part, the most significant incremental demands that we need to explain. That goes down here, that this part here, the orange. And we see our aggregate event impact seems to be high enough to match it, to explain it. So in this case, we can get more insights as well. We see that the incremental demand is going over about 5 days, and the first 2 or 3 days is before the events, which makes sense because people will arrive to celebrate certain events or to participate in certain events a day or 2 earlier. We call this like lags, and different industries will have different lags. Those events happen to have 2 days in advance. And we can see other correlations too, like with this one, this event seems to explain this part, and this explain this part. So we can see correlations through these charts, and we can identify where those events that's caused it as well. So what we could do here is to go back to 317, where we have the high impact events, and see what they are. And one manual way to handle it, just now you have those events, you're aware of them, so you can take them into consideration with your forecasting. Another way, which is using the next step. Now, once you have this correlation, you identify it, you saw it here, then you can take those events impact data and incorporate it as features, taking into consideration the lags for your domain, and just do your forecasting, including those events for enhancement. And another way you can see the correlation is by plotting the impact and the incremental demands against each other. With a lot of cluster here, it might be better to take the logarithmic scale. And if we take the logarithmic scales, plotting the impact logs against the incremental demand logs, we see some obvious correlations here. So I hope this was helpful, and I'm happy to answer any questions by emails or in person. Thank you for listening.